Ensuring electrical safety in the mountains is no small task. Ski lifts, gondolas, bike parks, and remote alpine systems operate in harsh conditions and serve thousands of people every day. That is why safety must remain uncompromising. By applying the right techniques, using the right tools, and choosing the right timing, even demanding mountain inspections become smooth and productive. We at Metrel can make that happen, delivering the only comprehensive solution for electrical safety testing, reliably supporting operations in both winter and summer. Winter testing lets us measure grounding during operation. It is fast, efficient, and convenient, even on snow-covered terrain. When summer arrives, we shift focus to verifying tower grounding individually, combining accessibility with precision. Summer testing is becoming increasingly critical as ski slopes, once covered in snow, transform into popular trails for hikers, mountaineers, cyclists, and other visitors. Every year, lightning strikes damage ski lift cables, forcing shutdowns that lead to costly repairs and lost revenue. In severe cases, entire installations can even catch fire. During summer, inadequate grounding adds another serious risk: dangerous touch and step voltages around ski lift infrastructure. To ensure safety and efficiency, testing should focus on touch and step voltage measurements, since using incorrect methods not only wastes time and inflates costs, but also compromises safety. This is where Metrel makes the difference. We offer a comprehensive range of advanced and versatile testing solutions, from systems designed for intensive use in demanding field conditions, such as the MI3295 Step Contact Voltage Measuring System, the MI3290 Earth Analyser, or the MI3144 Euro-Z 800 volts, in combination with the MI3155 Eurotest XD. At the other end of the spectrum are compact, portable testers, such as the MI3288 Earth Insulation Tester, built for mobility without compromise on accuracy. These products, combined with specialized training, empower professionals to master safe and efficient electrical testing in the winter and throughout the entire year. Why wait for summer when all essential measurements can be performed in winter? Our robust solutions make measurements easy and reliable, even in challenging winter conditions. We start by identifying the grounding system at the lower station. This involves checking continuity with a 2-amp current, using the accurate 4-wire method between the drive unit and the carrying cable, and verifying connections to earth. After that, we apply the 2-clamp method to determine whether the system is unified or isolated. This step answers the question, are the towers locally grounded or linked to the station? Once this is clear, we proceed with the 3-angle method, using extension leads and auxiliary probes to measure the grounding resistance of the lower station. For this, we use the Metrel MI3290 Earth Analyser and a shielded cable connected to a remote probe, applying the 4-wire measurement method for maximum accuracy. To enhance precision, a unique Metrel sweep setting enables frequency-based testing up to 15 kHz. Low-frequency results provide insight into the entire grounding network, while high-frequency readings focus on the local grounding of the station itself. This comprehensive approach is suitable for both small installations and large-scale systems, ensuring consistent and reliable grounding verification across all setups. Winter is the perfect time to begin, because many tests can be performed while systems are operating. When the carrying cable is grounded during operation, testing becomes simpler. In our case, the cable was not grounded, which required additional steps. Yet the process was still faster and easier than traditional methods. Preparation remains straightforward. We use a G-clamp to ensure solid contact with metal surfaces, even when they are covered with thick paint or rust. To achieve more accurate and reliable measurements, the 4-wire Kelvin method is applied. A communication headset is also essential, enabling clear coordination with the gondola operator throughout the testing process. The inspector moves along the gondola or chairlift system using the lightweight MI3288 tester to perform local potential equalization with test probe, and with that, it creates a loop through the grounding. The inspector performs grounding resistance measurements for each tower. Working closely with the gondola operator, the system is stopped at each tower to allow testing. During each stop, the operator grounds the system at the lower station. The inspector then uses an extension rod to make temporary contact with the tower's conductive structure. The MI3288 test creates a voltage funnel between the lower station and the local tower, measuring the combined resistance of both and saving results for later reporting. These steps are repeated at every tower until the job is complete. Another option is to use the MI3290 tester at the lower station for testing with the grounded carrying cable. In that case, remote assistance at the local tower can be provided by any maintenance team member, eliminating the need to operate the tester. Only a local connection is required between the gondola and the tower's conductive structure. We also use the 2-clamp measuring method with the MI3290 tester. Its memory structure allows easy navigation and later reporting. In both cases, every tower is tested to measure its resistance to Earth. The entire line of towers can be completed in less than an hour. This is a significant improvement compared to the traditional approach, which involves walking from tower to tower during hot summer days, while carrying heavy loads, reels, and probes for several days. Chairlift systems often involve more towers spread across wider terrain, making inspections even more time-consuming. This is why winter conditions offer a clear advantage, providing easier movement, more enjoyable work, and greater efficiency. With Metrel's MI3288, supported by expert training and proven techniques, inspectors can perform precise measurements with speed and confidence, even in complex mountain environments. We begin by connecting the 4-wire extension leads to the G-clamp and the extension rod, allowing temporary contact with each tower. Using the MI3288 tester, the measurement procedure is straightforward and identical for both gondolas and chairlift towers. But it requires the use of the Kelvin method to ensure accurate and reliable results. Finally, the tester is set to Earth mode. At each stop, the operator grounds the carrying cable at the lower station, unless it is already grounded during operation, which saves time. The inspector connects to the conductive part of the tower using a dedicated adapter and performs a 4-pole earth test. The MI3288 generates the test signal and accurately measures the grounding resistance. Expected results for tower grounding are typically within the ohm range. When resistance reaches 1.1 kiloohms, as in our case, the tower requires immediate repair or reconnection to the earthing system. Harsh weather conditions and temperature fluctuations gradually degrade contact quality, which makes regular inspections essential. This procedure is carried out at every tower, from the base to the top. Step by step, we verify that each structure is properly grounded, ensuring safety throughout the entire system. Depending on the team's competencies, we choose the appropriate workflow and measuring equipment. In this case, we use either the MI3290 Earth Analyser or the MI3288 tester. All measurements are performed by the inspector at the lower station, while a team member carries out local grounding at each tower during system stops. This method gives the inspector greater flexibility to apply various testing techniques and perform comparative measurements with precision. Some ski lifts are grounded in a different manner and have all the towers interconnected with metal straps, all the way from the top to the bottom station. For such situations, the MI3288 tester's microohm mode with 2 amps direct current mode should be used. Using the 4-wire measurement method is essential, as it ensures high accuracy even when the electrical contact between the measuring accessories and the test object is poor. The manner of performing the measurements is the same as for other kinds of ski lifts. The operator grounds the carrying cable at the lower station, unless it is already grounded during operation, while the inspector connects to the conductive part of the tower using a dedicated adapter and performs the 4-wire test. In recent years, More mountain systems are used for summer activities, such as cycling. Downhill trails, hiking and tourism. These installations may offer shelter during storms, but caution is needed because most grounding systems were designed for winter operation when snow provides natural insulation. During summer, the risk increases significantly. Without snow or protective clothing, people and animals near these systems are more exposed. This is why it is essential to test for touch and step voltages. These measurements reveal hidden dangers caused by aging, corrosion, material washout, or installation errors. Neglecting protective measures can be fatal. Even in summer, terrain movement can remain fast and efficient when the right measuring equipment offers portability, robustness, and durability. During testing, the system is stopped and grounded at the lower station, and often at the upper station as well. This prepares us for step and touch voltage measurements. The team progresses from one tower to the next in a coordinated manner. While one operator prepares the generator, test plates, test leads, and connections for the MI3288 tester, the other climbs the tower to attach the measuring lead to the carrying cable. The test lead from the top of the tower is lowered to the inspector, who connects the MI3288 tester between the cable and the tower. Two G-clamps are used to secure the measurement leads, and the test begins. For accurate evaluation of touch voltage, two test plates are connected to simulate bare feet on ground contacts, while the A1597 human body resistance probe represents the resistance of the human body. Tests should be executed at different positions around conductive parts at a distance of 1 meter. Step on the parallel connected plates and start measuring touch voltage while generating a test current between the tower and the remote grounding. Before starting the measurement, ensure that the fault current is set to a minimum of 50 kiloamps. Every measured touch voltage higher than 716 volts represents a dangerous situation and requires appropriate reporting and repair. From the instrument screen, we can read many other important sub-results, including the resistance RC, where 2 ohms represents the remote grounding of the lower station. Step voltage measurements can be performed using a 100 milliamps test current, ensuring a safe procedure while still providing valuable insight into ground potential distribution and grounding system behavior when fault currents reach 50 kiloamps or more. Touch and step voltage must be tested along the entire route of system-built installations and their grounding networks. Exposed metal straps on or near the surface can pose additional risks, especially during lightning events. This is why step voltage testing is extended across longer distances. In these cases, probes are placed 1 meter apart to simulate realistic conditions and detect potential hazards. These measurements do more than confirm compliance. They reveal risks caused by poor installation, corrosion, or environmental wear. When results stay below 716 volts, we know the system offers a safe response during a lightning strike. In summer, new risks emerge as newly installed equipment, water lines, trails, and downhill tracks come closer together. Older systems were not designed for this expansion. Their grounding layouts often lack protective branches, rings, or mesh structures in the soil. Without proper upgrades and testing, these systems may expose people and animals to dangerous voltages during storms. Preventive testing is not optional. It is essential. Grounding resistance measurements not performed during the winter period may additionally be carried out during summer inspections. After testing for touch and step voltages, we extend the setup using a 50-meter measuring lead and a probe from the equipment kit. Next, we apply the Earth 4-point method by placing the probe 30 to 50 meters away from the tower, perpendicular to the grounding path. This captures the full voltage funnel around the tower, while current flows between the tower and the remote grounding at the lower station. For deeper analysis, we use different frequencies during measurements. The sweep function, which was already demonstrated in this video, provides a graphical overview across multiple frequencies and helps us identify both local and distributed grounding characteristics. When towers are connected in parallel by a metal strap, low-frequency testing will show low impedance ZE, for example, 0.401 ohms. Increasing the test frequency reveals more local grounding of the separate tower, so the expected results will be higher. After completing all measurements, we carefully remove all leads and probes from the terrain. A portable, robust, and durable equipment package is essential for ensuring electrical safety in demanding environments. With this approach, we can cover large sections of mountainous terrain in a single day, sometimes even the entire slope or system. Confident that the job was done professionally, we head back down to the valley.